Hi, this is Sir Absolon of Math Alas channel and welcome once again in another episode of Learning in Mathematics.
What is series? A series is the indicated sum of the terms of a sequence. For the arithmetic sequence 3, 5, 7, and 9, the arithmetic series is 3 plus 5 plus 7 plus 9. In simpler terms, we are just adding the terms of the arithmetic sequence from the first term, or a sub 1, up to the last term, or a sub n.
Before we continue, Adi, Kuya, Nene, Tete, please subscribe to my daddy's channel, Salamat.
Let's try this. What is the sum of the first 100 natural numbers? Did you know that this problem was given to an elementary student named Carl Friedrich Gauss to keep him busy? And in just a matter of seconds, he was able to solve it. Do you know how he did it? Let's find out. Let's take 1 plus 2 plus 3 plus 4 up to 100. If you add the terms from 1 to 100 from left to right, it can be exhausting. So let's unfold the secret of Carl. When you add 1 and 100, you will get 101. If you get the sum of the next pair, 2 and 99, that will give you 101. If you add the next pair again, 3 and 98, you will get 101. If the terms in the sequence are paired in this manner, you will get 50 pairs because you have 100 terms in the sequence, right? So, what Gauss did is he multiplied 101 with 50, since there are 50 pairs in the sequence. So, in just a blink of an eye, he got the answer. So, the sum of the first 100 natural numbers is 50 times 101, and that is 5,050. Now, we will use the same technique in deriving the formula of an arithmetic series. Let's denote the sum of the first n terms of arithmetic sequence a sub 1 plus a sub 2 plus a sub 3 plus up to a sub n as s sub n. We can rewrite the sum in reverse order, that is s sub n equals the last term, which is a sub n, plus a sub n minus 1, plus a sub n minus 2 up to the first term. Rewriting the two equations above, using the preceding terms and the common difference, we would have s sub n equals the first term plus the quantity of the first term plus d, that's the second term, plus a sub 1 plus 2d, this is the third term. Up to the last term, we know that the last term, a sub n is equal to a sub 1 plus the quantity of n minus 1 times the common difference. Now, the other equation is s sub n equals a sub n, that's the reverse order of the sum of the sequence. So, a sub n plus the quantity of a sub n minus d, meaning that's the second to the last term, plus a sub n minus 2d, that's the third to the last term, plus up to a sub n minus the quantity of n minus 1 times d, which is the first term. Now, if we add these two equations, you will get 2s sub n equals, now, you will have, if you add a sub 1 and a sub n, you will have a sub 1 plus a sub n. Now, if you add the second term and the second to the last term, you will have a sub 1 plus a sub n because you can cancel d. Next is, if you add the third term of the sequence, a sub 1 plus 2d, with the third to the last term in the sequence, a sub n minus 2d, you will get a sub 1 plus a sub n, up to when you add the first and last term, which is a sub 1 plus a sub n. Now, as you can see, since there are n terms of the form a sub 1 and a sub n, then we can rewrite it in this way as n times the quantity of a sub 1 plus a sub n, because there are a number of terms of the quantity of a sub 1 plus a sub n. So, to get the sum, so we divide both sides of the equation by 2, then we will have the first formula, which Carl Gauss used. S sub n is equal to n divided by 2 times the quantity of the first term plus the last term. So this formula can be used if you have the first term, the last term, and you know the number of terms in the given sequence. There are times the formula S sub n equals n over 2 times the quantity of the first term plus the last term cannot be used if you don't know the last term. So, we know that a sub n is just the same with a sub 1 plus the quantity of n minus 1 times d, which is the arithmetic sequence formula. So, we plug in a sub n with a sub 1 plus the quantity of n minus 1 times d. So, we combine like terms inside the parentheses. You will have s sub n equals n times the quantity of 2a sub 1 plus the quantity of n minus 1 times the common difference all over 2. So, in this case, you can use this formula to find the sum of the arithmetic series given the first term, the number of terms, and the common difference. So, here are the two formulas for arithmetic series. So, S sub n is equal to n over 2 times the quantity of the first term plus the last term. This formula can be used if you know the first term, the last term, and the number of terms in the sequence. On the other hand, the second formula, S sub n equals n times the quantity of 2a sub 1 plus the quantity of n minus 1 times d all over 2, can be used if you only know the first term, the common difference, and the number of terms in the sequence. So let's have example number 1. Find the sum of the first 20 integers. When you say 20 integers, you start with 1, 2, 3, 4, up to 20. Now, we know the first term is 1. We also know the last term of the first 20 integers, and that's 20. Now, we know that n is 20 because you're dealing with 20 terms in the sequence. So, we will use formula number 1. Now, we substitute the values of a sub 1, a sub 20, and n to the formula. So, you'll have s sub 20 equals 20 over 2 times the quantity of 1 plus 20. Now, simplifying the right sides of the equation, you will have 1 plus 20 is 21. Now, 20 divided by 2 is 10. Now, 10 times 21, you will get 210. So therefore, the sum of the first 20 integers is 210. Let's have example number 2. Find the sum of the first 10 terms of the arithmetic sequence 5, 9, 13, 17, up to so on. The question is, what are the given in this problem? We know that we have the first term, which is 5. We have the number of terms, which is 10. Now, since we don't know the last term, so we will use the second formula. So we have to take the common difference. So the common difference in this case, 5, you have to add 4 to get 9. When you add 4 to 9, you get 13. So the common difference is 4. So let's use the second formula. S sub n equals n times 2a sub 1 plus the quantity of n minus 1 times d all over 2. So we substitute the values of a sub 1, d, and n respectively. So you have 10 times the quantity of 2 times 5 plus 10 minus 1 times 4 all over 2. So as you can see, we have to simplify first the terms, the expression inside the bracket and parentheses. So you will have 2 times 5 will give you 10. 10 minus 1 is 9. So again, we start inside the parentheses in the bracket. So you'll have 10 plus 36. You get the 36 from 9 times 4. Now, we have 5 here. We have taken this by dividing 10 by 2. So, now we have to add 10 plus 36 will give you 46. And then, you multiply it with 5 will give you 210. So therefore, the sum of the first 10 terms of the arithmetic sequence 5, 9, 13, 17 is 230. Again, we use the second formula because you don't know the last term. Please pause the video and try these exercises. And don't forget to type your answers on the comment section.
That ends our lesson for today, and this is Sir Sunny Bugawisan of Matalas Channel. And always remember, in Matalas Channel, we are making mathematics more easy. Bye-bye! See you again next time!